back to your channel Get Useful. In this video, we are going to solve bubble sort. We'll also understand how bubble sort works, and we are also going to see how to implement bubble sort in Java. Here in this slide, you can see two arrays. One is unsorted and the other is sorted in ascending order. We'll also see how to make this unsorted array sorted in ascending order using bubble sort. So please stay tuned. We'll go through each and every single step, don't worry about it. But let me give you a basic introduction of bubble sort. Bubble sort is a simple sorting algorithm that repeatedly go through the array. It compares adjacent elements. Adjacent elements means the next element. It compares with the next element, as you can see in the every single step here, and swaps if they're in the wrong order, like if you're checking in the ascending order, and if the number next is greater, then we will swap it. We will swap the adjacent element. So after each pass, you can see here we have 5 passes, right? After each pass, the number of unsorted elements reduces. In the first sort, one element is sorted, that is 52. In the second pass, 2 elements are sorted. In the pink color you can see. In the third sort, 3 elements are sorted. Fourth pass, 4 elements are sorted. So at each and every pass, the number of unsorted element reduces. Okay. Now let's go and see step by step how bubble sort works. So consider this array 38, 52, 9, 18, 6, 47. What are we supposed to do? We are supposed to compare the adjacent elements and swap accordingly. Now 38 is less than 52 and we are sorting in ascending order. So there is no swapping. Now 52 and 9. 9 is minimum. So swapping 9 and 52. After that, we'll compare 52 and 18. 18 is small, so swap 18 and 52. Now comparing 52 and 6. 6 is small, so swap. Now comparing 52 and 47. 47 is minimum, so swap. Finally, 52 is the highest element. We are sorting in the ascending order. So 52 is fixed at the last position. So in the first pass, one element is sorted. Going to the second pass, 38 and 9. 9 is the minimum element, so we swap it. Now 38 and 18. 18 is the smallest element, therefore we swap it. Now 38 and 6. 6 is the smallest element, therefore we swap it. Now 38 and 47. 38 is small, that's why we don't swap it. So 47 is also fixed. So 47 and 52 are the sorted paths. Now moving to the third pass. Here 9 is minimum and 18 is greater than 9, right? So we don't swap it. Now comparing 8 and 6, we swap it because 6 is minimum. Now comparing 18 and 38, 18 is minimum, therefore we don't swap it. So 38 is sorted now. Going to the next pass, 9 and 6. 6 is the minimum element, right? So we swap it with 9. Now 9 and 18. We don't swap it because 9 is minimum. So 18 is fixed here. Going to the next pass, we are not swapping it because 6 is the minimum element. Remember, whenever there is no pass, whenever there is no swapping happens in the pass, then we will stop the iterations and then we will declare that the array is sorted. So we are not swapping anything, therefore no swap, therefore array is sorted. Now let's understand the code here. In the main function, you can see we are creating an array with the elements 38, 52, 9, 18, 6, 47, and we are passing this array into the function bubble sort. Once we get the result from the function, we will run a loop and traverse to each and every element of the array and we will print the array. Now understanding the bubble sort function, first we are passing that array to this function. After that, we are creating a variable n which stores the length of the array. After that, we are creating a boolean variable swap. What is meant by a boolean variable? It either returns true or it returns false. Okay. Now speaking about the loops, for loops. The outer loop iterates from the first element to the last element. So it is used to traverse the entire array. Okay. At the beginning of each pass, that is inside the outer loop, a boolean variable swap is set to false. Okay, after running the inner loop, if the swap value is changed, then first pass or second pass will occur. If the swap is not changed, which means the array is sorted. Okay, by default, let's keep it as false before running the for loop. So now coming to the inner loop, that is inner for loop, it iterates from j is equals to 0 to the last unsorted element of the array. How do we say the last unsorted element of the array? That is n minus I minus 1. Okay, why n minus I minus 1? Comment below, because we have already discussed in the illustration of that example. Now in the inner loop, what are we doing? We are swapping, we are comparing the adjacent elements. If the current element is greater than the next element, then they are swapped, or else we move to the next set of elements. Okay, and if a swap occurs during the pass, swap is set to true. So before running the inner loop, we have set the swap value to false. If there is a swap, if we are swapping the elements, then we are updating the swap value to true. Once we come out of the inner for loop, after each pass, we check if swap is still false. See, you can see if not swap, then break, right? So if no swaps occurred, it means the array is already sorted. So the algorithm breaks out of the outer loop early. And this sorting continues until entire array is sorted or until a pass is completed without any swaps, indicating the array is sorted. I hope you understand the algorithm. If you have any doubts, please let me know in the comments below. Now speaking about the time and space complexities. The outer loop runs for n minus 1 iterations, where n is the number of elements in the array. The inner loop runs for n minus 1, n minus 2, n minus 3, and so on till it reaches 1, right? So, in the worst case and average cases, the inner loop makes n into n minus 1 by 2 comparisons and swaps. Therefore, the time complexity is dominated by these comparisons and swaps, resulting in O of n square. Even if the array is partially sorted or fully sorted, bubble sort still performs all the passes, makes it inefficient for large datasets. Please remember. Now, speaking about space complexity, the space complexity is constant, that is O of 1, because it uses a constant amount of space and it does not uses any extra space. So we are creating variables like n, boolean, swapped, etc. The algorithm performs all operations in place only without modifying the input array, right? So the space complexity is constant. I hope you understand this video. I hope you like it. If you like it, please like it, share it with your friends, and subscribe to our channel. Get this soon. Thank you so much for watching till the end. Bye bye.